In an earlier chapter, we looked at linear functions, which is when you have a constant addition or subtraction. In this lesson, we're going to look at exponential functions and see what that means. Now, exponential functions are not linear. So first thing we're going to fill in is an exponential function is a non-linear function of the form y equals ab to the x. So you're like, well, if it's not a line, then what does it look like? As the independent variable changes by a constant, the dependent variable is multiplied by a constant factor, which means consecutive y values have a constant ratio. If you remember from linear functions, they had a constant addition or subtraction, so we could kind of find the slope between the two values. It was constant in terms of the rate of change. Here, it's being multiplied. So down in example 1, we have to figure out if something represents a linear or nonlinear function. So in letter A, you can see that we did this a few lessons ago. You can see it's being added by 2 every time. If you remember, that made it linear. But now what we're going to do is we're going to look at things like letter B, where it's being multiplied by the same number every time. And that makes it nonlinear, which now we're going to call exponential. Before we look at what these look like in graphs, I know you're all probably super excited. Let's just evaluate some functions. Evaluate means find the answer. So we're going to do in letter A, y equals -2 times 5 to the third, because they tell us the x value is 3. So then we do order of operations. Y equals -2 times 5 to the third is 125. So that gives me -250. All right, let's do letter B. Y equals 3 times 0.5 to the -2. So you can just type that in your calculator. Y equals 3 times, that gives me 4. And so that gives you 12. And you say to me, Miss Lean, what if I don't have my calculator? Well, first I would say, shame on you. You should always have your calculator. But what you would do is you would do 0.5 is 1/2. So 1/2 to the -2. We did a lesson on negative exponents. That means you do the reciprocal and raise it to the positive exponent. And so you can see that's where the 4 comes from. This little blurb right here, exponential functions, I'm going to say that you can just read it, and if it's helpful to you, that's great. But we're just going to make tables and look at our graphs, but this is what they're going to look like. It's going to look like a curve, and you've probably seen examples like this before. You just didn't know that they were called exponential, maybe, or maybe you did. But the way that it curves all depends on what that base is, and if there's a coefficient, the coefficient would impact it as well. So we're going to graph one, and the steps are written out because we're beginners at this. The first thing we're going to do is we're going to make a table of values. That's the XY chart. Then we're going to plot the points, and then we're going to draw a smooth curve through the points. Now this is not linear, which means we're not going to connect it with lines. We're just going to connect it with a freehand smooth curve. So the first thing that we're going to do is make our chart. So I've got X, then I'll write my equation inside. 4 times 2 to the x, then I'll get my y value, and then, we'll plot our points. So when you pick the points, you should pick a positive, a negative, and 0. So I'm going to do -2 to 2. That's my suggested range for you, unless you for some reason feel like there should be another range. Negatives, positives, and 0. So now I have 4 times 2 to the -2. Calculator powered up. So this gives me 1. Then I have 4 times 2 to the -1. That is 2. 4 times 2 to the 0 is 4. 4 times 2 to the first is 8. And 4 times 2 to the second is 16. So you can see my x's are positive and negative, but my y's are only positive. So I'm going to kind of get rid of the negative y quadrants and put it in the positive y quadrants. So that's the grid that I'm going to make. You don't always have to do the origin centered right in the middle of the grid. So now let's plot our points. And let me go by 2's on the y-axis. Let's see, can I fit 2? Oh, perfect. If I go by 2's, I can fit, right? But I'll just go by 1's on here. So -2, 1 would be right here, because I'm going by 2's. -1, 2 is right there. 0, 4. 1, 4. Wait, what? 1, 8. And 2, 16. So you connect it using a smooth curve. And I'm going to tell you that this kind of flat lines right here shortly after that bottom when you kind of see them clustering together. And that has a special name. It's called an asymptote. That's how you spell it. And an asymptote is a line that the graph gets really super close to, but it doesn't touch. All right, so there's our graph. Now we have to compare the graph to the graph of the general parent function, which is the one that would just be like y equals 2 to the x. We'll do that in class. Let's save this, and let's save the describe the domain and range for class as well. I want to just focus on getting you comfortable with graphing. And then we'll look at the comparing and describing later. All right, let's scroll down to example 4. So in example 4, we have -1/2 to the x, but the steps are still the same. Let's make our xy chart. So we've got x, then we have -1/2. Be careful, the negative is outside the parentheses. And then we have y. So I'm going to do my range, -2 to 2, because nobody's telling me that I should use another range. So let's do it. So I have -1/2 to the -2. 1/2 to the -2 is the same as 2 to the +2, which is 4. So this gives me -4. Now I do -1/2 to the -1. I'm just going to space my x values better. -1/2 to the -1 is 2, so this gives me -2. -1/2 to the 0, well, anything to the 0 is 1, so this actually gives me -1. Then I have -1/2 to the 1. Well, 1/2 to the 1 is just 1/2, so that gives me -1/2. And then I have -1/2 to the second. 1/2 squared is 1/4, so this gives me -1/4. So now you see my y values are all in the negative quadrants. So when I make my grid, I'm going to do the opposite of what I did last time, which is put myself in only the negative quadrants. And I don't think I need to go by 2's because my numbers should fit. So I'm going to graph -2, -4. Then I'm going to graph 0, -1, -2. 0, -1. 1, -1/2. And 2, -1/4. And so you can see the dots are clustering. So that's going to be where my asymptote is happening. So kind of flat lines. And so this one is going to be the reverse direction. Down at the bottom, there's a little fun fact, and it helps you figure out how to do a graph without having to go through that crazy chart. So take a second to read this, And then let's go on to using one and see how it works. So they want us to graph this super crazy looking equation. And then down in step 1, they actually say that it's related to the one that we did in example 3. So why don't we pause for a second, flip back to example 3, copy the chart, copy the graph, and then I'll show you what we do. So what we're doing now is this equation tells us that we're going to take this graph and we're going to go 3 units right and 2 units up. We did this shifting when we talked about absolute value graphs, so if you have no memory of the shifting, go back and find the absolute value lesson. So one at a time, we're going to take a dot, we're going to move it 3 to the right and 2 up, but remember we went by 2s, so 2 up is really one box. So that first dot is going to shift right there. Okay, so now we take the next dot and we go 3 to the right and 2 up right there. Okay, next one, 3 to the right, 2 up. Oops. Next one, 3 to the right, 2 up, 3 to the right, 2 up. Lands right there. Oh, right on my grid. All right, so we've got our asymptote, and that's the graph. So you can see it's a little easier, but again, you could have always gone and done the chart. And we're going to describe the domain and range in class. All right, in the interest of time, we're going to skip example 6, and we're just going to move on to example 7. So we have this graph. It represents the bacterial population Y after X days, and they want us to write an exponential function that represents the population. So remember, the formula for an exponential function is y equals ab to the x, and I will tell you what these pieces mean. The a stands for the y-intercept, and the b stands for that ratio that you're multiplying by. So now if we have to write an exponential function, all we need to know is the y-intercept and the ratio. And I mean, it gets a little more complicated than this if you have a plus or minus or something like that. But the basic ones are written like this. So we have y equals, our y-intercept is 0, 3. And our ratio, you find out what we're multiplying by. So we're going from 3, then 12, 48, 192, 768. So how do you go to all those values? You multiply by 4. So it's going to be times 4 to the x. So that's how you write an exponential function. Now we're going to take our exponential function and find specific values. So 12 hours and 5 days. So 12 hours, if you look at the x value stands for days. So 12 hours is half a day. So what we do is we would do 3 times 4 to the 1/2. And we already know how to do fractional exponents. That's the second root of the square root of 4 raised to the first power. So it'll be y equals 3 times 2. So that's 6. So there'll be 6 bacteria at 12 hours. And then we do it again just for 5 days. And we don't need to change anything because the x value stands for days. So it'll be y equals 3 times 4 to the 5th. I don't know 4 to the 5th. I need to get my calculator out. That is 1024 times 3. So wow, this bacteria is multiplying pretty quickly. 3,072 bacteria at 5 days. All right, if you have any questions, write them down and ask me when you come to class.